Good evening, everybody. And now for the last talk. My name is Yvette Perfecto. I'm a faculty member here at the School for Environment and Sustainability. And I'm here to introduce you to Will Tarpeh. Will is a postdoctoral fellow in the Department of Civil and Environmental Engineering. And I think that we, although some of you have not given too much thought about the fact that fish pee, I'm sure that you're all aware that we pee. and maybe perhaps you haven't thought about pee as a great resource, but Will have thought about that, and his interest in sustainable agriculture combined with his interest in environmental engineering took him to this project that he's going to present to us today. And the title of the project is, the title of his talk is Pea Cycling, Creating Sustainable Fertilizer from Urine.
Good evening, everyone. Believe it or not, I'm often the only person in the group to be talking about pee, so I'm very excited today to be one of. I'm going to go with 3. I'm going to count that last one by Dr. Peterson. So today I'm going to talk to you about pea cycling, and we call this pea cycling for really 3 reasons. 1, because it sounds fun. 2, because we think a lot about cycles in our work and how to shortcut them and make them more efficient. And 3, because it really is related to recycling in terms of how we separate cans from plastic, from glass, to increase our recovery of those resources. We can do the same with our different wastewater pathways, wastewater streams like urine. Great, so let's start with our first cycle in terms of how nitrogen is currently managed in countries like the US. Wastewater is emitted from our households and businesses, and it goes to wastewater treatment plants. And if it's not removed, it's often emitted as ammonium into what we call receiving waters, these rivers, lakes, and streams. And that can lead to eutrophication if these waters are sensitive to nitrogen. And eutrophication is just as pictured here, these algal blooms that can be potentially toxic to aquatic ecosystems and even to human health. Now, as environmental engineers, we use a combined process called nitrification, denitrification, to remove this nitrogen from the water and protect our waterways from eutrophication. In so doing, we convert ammonium, NH4+, into nitrogen gas, which is the majority of the air we breathe, so it's relatively innocuous. Now, the paradox is how we produce nitrogen fertilizers, where we really reverse this process. We convert nitrogen gas back into ammonium that we apply as fertilizers. And we use a process called the Haber-Bosch process, which is one of the most energy-intensive processes in the world. It consumes 2% of all of the energy globally. And so what we're doing really is we're cycling nitrogen through these 2 energy-intensive processes that we end up applying to fertilizer, as fertilizer to our crops, and just goes through this cycle. So our research is motivated by this question. Why not recover nitrogen from waste directly as fertilizer and short-circuit this cycle and avoid these energy costs? And we combine really 3 sectors here: food, energy, and water. And this nexus is really what our project is about. So let's think about urine in particular. You may not know this, but urine is only 1% of our wastewater stream. So for every 100 gallons that come out of your house, only 1 gallon is urine. But it contains the majority of nitrogen, phosphorus, and potassium. You'll recognize these as the macronutrients that are present in most synthetic fertilizers. So urine is a highly concentrated, low-volume waste stream that's really ripe for resource recovery. As for how, it's no mystery here. For the men, we're used to seeing waterless urinals. For everyone, we have no mixed flush toilets. I'll show you a picture later of one we have here on campus, where there's a barrier between the urine and feces chambers. And even in settings where there's not conventional sewerage, we can use urine-diverting dry toilets, as pictured here from a toilet in Kenya with some of our fieldwork. So our project is called the INFUSE project. It's Innovations at the Nexus of Food, Energy, and Water Systems. And what we do is really 3 things. First, we evaluate urine processing technologies. How can we turn urine into fertilizer efficiently? Second, we assess risks associated with environmental quality and human health, both in terms of biological contaminants like bacteria, viruses, even antibiotic resistance genes, and in terms of chemical contaminants. Think of all the pharmaceuticals that we take and how you might not want those on your crops. Finally, we evaluate people's perceptions of urine-derived fertilizers, and we also advance communications both of risk and of the idea as a whole. This picture you see here is of our mascot for the project, Urine Nation is his name. And we have so this is an example of some of the public outreach we do, including surveys at lots of different festivals in both Michigan and Vermont. A little deeper into this project approach, what we're looking for on the left-hand side, we're looking at urine diversion. So this is some collection that happens in Vermont, and it's applied to crops. And also in the lab, we're looking at microbes and, like I mentioned, these pharmaceuticals. Then we assess the risk, going from the hazard identification, knowing what to look for and what risks are posed, all the way to the actual risk characterization. And finally, the communication, like I mentioned, of those risks with our videos, our public outreach at festivals, and also involving farmers in the process. Finally, what does this look like at UM? Here are some pictures from our installations in the G.G. Brown building on North Campus. Here's our waterless urinal. And then in the middle, you can see the source separating toilet that's in the female bathroom. And then right under it is what we affectionately call the urine room, which is right below the two bathrooms. And that's where we process our urine into fertilizer using reverse osmosis and distillation. So I'll end there and highlight our two PIs, Nancy Love and Krista Wigginton in Civil and Environmental Engineering. And Greg Kuehlein is actually also a part of the project here in Seas. And if you ever find yourself on North Campus near G.G. Brown at the intersection of Beale and Hayward, come on and give us a urine donation.